Let's discuss the another question. So far we discussed the first question, it was about the SSS criterion. Now let's discuss the second question. I told you that figure will be with you in the question, so here also we have the figure with us. Let's read the question. In the given figure below, O is the midpoint of AB and CD. Prove that AC is equal to BD. So we need to prove AC is equal to BD. Now how shall we approach it? Because if you see over here, these lines are not connected first of all, right? So how shall we approach this question? Plays very important role. So let's start. First of all, what's given? O is the midpoint of AB and CD. Let's write here that O is midpoint of AB and CD. So what we can write? Remember these words, midpoint. Midpoint means what? That this point O is dividing AB and CD into two equal parts, right? So what we can write? We can write that OA, let's write OA is equal to OB. It is marked as well in the figure, it's easy to write it. And then for CD, we can write that OC is equal to OD. We are going to use these conditions to prove the result, which is AC is equal to BD. So how can we prove that? First of all, let's draw a line for AC and here BD, right? We need to identify that which triangle are we supposed to prove congruent. Now see, AC lies in this triangle, right? So this is the triangle I think we need to prove congruent, and this is the another triangle where DB lies. Okay, this is how we need to think of very clearly. First of all, I told you identify which triangle are you supposed to prove congruent. So let's start with triangle AOC and DOB. Now if you observe one thing, that here two sides are given for this triangle AOC and DOB. So first of all, let's write all the conditions that we are aware of: SSS, SAS, ASA, AAS and RHS. So we have two sides with us, right? So either this one or either this one out of first two categories. Now see over here, third side, if we have AC is equal to DB, this sum doesn't make any sense at all because that's what we wanted to prove it. If that is given to us, then this sum is over, right? So we cannot use SSS over here, right? I told you the reason behind that, because we need to prove the third side equal. That we cannot assume as equal. Don't assume these things, right? So what we are left with? We are left with SAS, side angle side. And this angle is not any angle we are supposed to take, right? I told you this angle should be between these two equal sides, included angle. Okay, so right now if you see over here, let me just draw AOC, here A, here O and here C. So this and these two sides we are going to compare as equal. Now what is the angle between them? This is the angle here, right? And for this one, let's draw over here DOB, this is and this. These two angles should be equal. Now can we say they are equal? And if yes, based on what properties? Remember the chapter lines and angles, right? I told you that chapter we are going to use throughout the geometry, right? So if you observe, it is making X. Now X means what? Vertically opposite angle. So this angle here AOC and here DOB will be equal because they are what? Vertically opposite angles. So let's mention that vertically opposite angles. So we can write angle AOC let's write angle AOC is equal to angle BOD, angle BOD. Done? Now see, we have two sides here, right, and one angle. So let's mention the conditions. So first of all, let's start. OA is equal to OB, then angle AOC is equal to angle BOD, and finally OC is equal to OD. So by SAS criterion, we can write triangle AOC is equal to triangle BOD. Okay, this is being done, but this is what we wanted to prove in this question. No, we wanted to prove AC is equal to BD. So I told you previously we discussed corresponding part of congruent triangles are equal. So we can write by CPCT AC is equal to BD. Very simple it is, right? You just need to mention by CPCT AC is equal to BD. Let's recall what we did in this question. First of all, we had this two triangle arrangement kind of, and we wanted to prove AC is equal to DB. For that, you need to connect the lines first of all, right? That being done, now here one more condition was given, that O is the midpoint of AB and CD. So write the conditions. Remember, whenever condition is given, you need to express in the mathematical form. Students just keep thinking that what is midpoint, right? I know it is midpoint and I know it divides into equal parts, but this is what you need to mention it. This gives you very clear idea that this condition is very helpful by SAS criterion to prove the triangles congruent. So, right, we have AOC and DOB over here. So we have two sides equal, and we wanted to prove by SAS that these two triangles are congruent. So angle being proved equal by VOA, vertically opposite angle, and by CPCT we have written AC is equal to BD. So this is how we solve the sum with the SAS criterion.